So the talk today will focus on broad knowledge on AWS, and we'll show you some very basic stuff on AWS. And I try to manage to talk about things that are also understandable for people who are new to AWS. So the talk is Manage Your Connected Cars Serverless. So who am I? I'm a software engineer and cloud enthusiast. I'm a co-founder and CTO at APOINTMED, that's an e-health startup. And I'm a co-founder of Cloud Brothers. That's more or less a group of cloud enthusiasts to try to share knowledge in the community and to make it easy to learn things in the cloud. And I'm AWS Certified Solutions Architect. So let's go on. What's the agenda for today? Mainly I talk about connected cars in the cloud. So first of all, we talk about what a connected car actually is and why we started this project. And then I'll show you something about the architecture that I used in the cloud, which services I consume in AWS, and what's my experience with those services, or I try to share some best practice for those services. Yeah, let's start. There are a lot of cars in this world, and today there is a very small percentage of cars that are connected already, but it's a trend that's coming up, like every device is nowadays connected to the internet somehow, and the car domain is some domain that now accelerates and now starts to digitalize everything. So connected cars are the future, but actually the question is still unanswered, what's a connected car? So if you take electric car, all the electric cars are connected already, so that's a huge step in regards to innovation. And if you take a car and plug in a cable, you get a connected car, hopefully not something like this, but a real car. And so actually a connected car is fully connected to the internet. That means it can communicate and send data and also receive remote commands. So for example, for a Tesla, you can remotely unlock or lock the Tesla or access some data from the Tesla, or you also can control your climate, so you can pre-cool or pre-warm your car completely remotely. Actually, a car is some huge IoT device. So you can send data, you can receive data, but the data is hardly usable for customers. So you can access those data on a technical level, like using a REST API, but you cannot put some meaning to this data. So that's the problem. People can access their data through the official app, but they cannot access all the data, and they cannot connect those data with each other. So they're more or less just huge packages of data and nothing more. So my goal was to make sense of all this data. I want to combine those. I want to evaluate driving, charging, parking states of the car, and want to put them together and create some meaningful statistics. So actually I want to answer the question how many miles or how many kilometers I drive each week. And I couldn't answer this very easily, and I'm a very lazy developer, so I don't want to take notes and calculate at the end of the month. So that's why I want to automate those things and create some statistics automatically. And then there was a circumstances some time ago that a friend of mine wanted to drive my car during my vacation, and I had to give him my app credentials, and he could completely control the car during my vacation. And this is something you don't want to share your credentials for your car with some friend, and then you have to change those credentials after your vacation. So it's kind of, best practice would be to have some kind of user management, and you can access, you can grant temporarily some permissions to users and then revoke those again. So this was also a goal for me, because I know this friend want to drive the car again, maybe in future. So then I don't want to share my app credentials with him. And maybe analyze those data and do some magic with it. So maybe some forecasts, or do some calculations that I might think of in the future. So My goal for the architecture was it should be quite managed, so I don't want to take care of servers, I don't want to take care of operating systems and stuff like that. It should be cheap because it's a side project, not a commercial one. It should be reliable, of course. Every infrastructure and architecture should be reliable today. Resilient, high uptime, that's also very important values for such a project. Configuration over implementation means if I want to change something in the architecture, I don't want to implement it, I rather want to configure it. And it should be scalable, because if some people join this project and want to use this application for their connected cars, it should automatically scale. So I want to invest some effort to change the architecture infrastructure to be capable of dealing more with cars or vehicles. It should be documented. So if I want to work on this project in 1 year from now on, I want to know how I did those things, and want to have some kind of documentation to continue working on this project. It should be maintainable, so it should be very easy for me to continue working on the project. It should be automatable, so I don't want to have some manual steps doing all the time. It should be completely automated. It should be versioned, so I want to see the history of my architecture and the history of my infrastructure. It should be very easy to implement. I don't want to invest a lot of time on studying on Google and stuff like that to get something to run. And it should be 100% serverless. So that's also a very big asset nowadays for applications in the cloud. So if you sum all those things up, you get a eierlegende Wollmilchsau. I don't know the English word for that. But if you type in eierlegende Wollmilchsau in Google, you get this picture. Not quite accurate. So I tried to find another one. Okay, no, that's the first time. Well, what's serverless? Who of you already know what serverless is? Okay, let's go through it quite fast. Serverless means you don't have servers, no servers at all. You just have to don't manage servers anymore. So that means no operating system versions, no patches. In the best case, you don't have to manage deployments or uptimes or configuration management. All that stuff is done for you. Of course, it reduces your operational costs, your dependencies and your complexity, and it automatically increases your flexibility and reliability. So the services I used for this project are listed here. It's starting with LAMBDA, of course, if we talk about serverless and AWS. Then I used APIGATEWay, SNS, so simple notification service. I used the STEPFUNCTIONS, DYNAMODB and CloudFormation. I used CloudFRONT S3, Web Application Firewall, CloudWatch, CloudTrail, KNS, so Key Management Service, X-Ray and Cognito. So let's break it down, what each service does for this application for me. More or less, this is what I use. This application model shows the main application. So I use CloudFRONT, as I said, and I completely trust on LAMBDA, so I don't have an EC2 instance running anywhere, so it's completely serverless. And let's start with CloudFormation. So who of you already uses CloudFormation? Okay, not many. With CloudFormation you can create infrastructure as code. There are a lot of tools on the market that do similar things like Chef and Puppet and all that stuff. CloudFormation is AWS specific. In this case I versioned the infrastructure in Git, and most of the upgrades that are done by CloudFormation are with zero downtime. That means if you upgrade, if you tag something, if you create some extensions to your resources, mostly of those don't require the resource to be not available anymore. Of course, if you replace some tables in a DynamoDB, then you get downtime. And I use it in conjunction with CodePipeline. So the first thing I do when I start a CloudFormation project is to create a master pipeline that updates itself. So that means if I change something on the initial CloudFormation template, I want the CloudFormation stack to be updated itself, and that you can do with by using CodePipeline and having a master pipeline that updates itself. That is quite easy possible with CloudFormation. S3, yeah, everybody knows S3. If you use AWS, it's just object storage and very durable, cheap and reliable. And I use it to store the front-end files, so the application files for AngularJS application. Next, best practices for S3. Well, not many people use bucket policies. It's quite strange, but I often see some configurations for S3 without bucket policies, so that's definitely one best practice to use those, as well as versioning. So versioning is a very, very big asset of S3, and not many people use it actually. Who of you use versioning for S3? Okay, 4 hands, all right. And yeah, make use of storage classes. So you might have files that you don't access that often, so just make use of storage classes and reduce your costs for S3. Next, the CloudFront. It's a classical content distribution network and delivers the file stored on S3. It provides an easy mechanism for caching and invalidation, and you can define easily your caching behavior for several patterns of files. DynamoDB, I decided to stick with a NoSQL database because in this use case I could design all the patterns without a relational database. And the only thing you have to do in DynamoDB, you have to pre-provision throughput capacity. So that's the only thing that comes with pay as you go, but you pay as you go a little bit upfront, so you cannot really have zero costs with DynamoDB. And the latest feature is that you have auto-scale throughput capacity. That means if you define some throughput capacity for DynamoDB and some people join your project and the capacity is increased, DynamoDB automatically adapts those throughput capacity for you, and you just pay the differences. So it scales down as well, so it automatically scales your capacity. And actually DynamoDB is for you clustered in a multi-AC environment, so runs on SSD drives, so it's very, very fast, and for millions of entries you can still have access times less than 10 milliseconds. DynamoDB is used in this project for account data, plans and subscriptions, of course, for the encrypted remote credentials to access the car remote API and then retrieve the data from there, and of course the vehicles itself, so that I know which account does own which vehicles, and the statistics, the data sniffing records, and the aggregated data. So the complete persistent storage in this project is based on DynamoDB. Well, LAMBDA, everybody knows LAMBDA, right? Is there someone who does not know LAMBDA? Really? Okay. That's sorry. Well, okay. No problem. Let's get started with LAMBDA. It's actually a function as a service. So rather than defining a server where you deploy your application, you just write code and let LAMBDA or AWS execute those code parts for you. And you can use Node.js, Java, Python or C# for developing your application. And you have two different ways to invocate your LAMBDA function. It could be either an event, so it's asynchronously, it returns immediately, and you can have some execution running still in the background, or you have a request-response pattern, which is the most common one for using LAMBDA. And AWS started, I think last year with SAM. It's the serverless application model, and it's AWS tries to create a description language for serverless functions. That means with SAM they created some kind of CloudFormation similar description language that could be used by other cloud providers as well. So Google or Azure or others could actually make use of SAM, and you describe how your function is invoked, which are the configuration parameters, the environment variables, and you can theoretically use SAM to describe a function for cloud, for the Google Cloud as well. But this is still supported only by AWS, as far as I know. But I think it's the right step in the right direction for creating kind of standards for serverless applications. Well, with LAMBDA, you just have pay as you go. So you really pay just the executions that you fire. And every AWS account, even those that are out of free tier, of this 1 year free tier, get 400,000 gigabytes seconds a month for free. And the gigabyte second is actually, if you have a Lambda function that is configured to use 1 gigabyte of memory, and it runs for 1 second, then that's a gigabyte second. So that means if you calculate those down, if you break it down, 1 gigabyte second costs you 0.401667 US dollars. And that means that you have 1 million gigabyte seconds, which is equals to 11 days. Execution of your Lambda function costs you around $16. And if you don't use 1 gigabyte memory, but rather 128 megabyte, which is more than enough in this project, for example, if you use Node.js, then you could let your Lambda function run for 92 days without any break, and you just pay $16. So that's very cheap. And you can have the slides afterwards. Here you find a pricing calculator for Lambda, and you can play around with it and have a look how much you really pay if you use Lambda for your project. So the best practice for Lambda actually, there might be some situations in which you want to call another Lambda function from a Lambda function. In this case, I would prefer to use a REST interface for that, because if you have cascading invocations, you trust on very vendor-specific interfaces. So you know you have to know how to invoke another Lambda function. And in this case, you easily create dependencies between different Lambda functions and different code segments. I rather use REST interfaces. You can define access controls very easily with APIGATEWay, and rather call it REST API instead of invoking in a cascading way other Lambda functions. Then use X-Ray. So X-Ray is a very great tool for monitoring your invocations, and you can really break down some very problematic parts of your code and see how long remote calls really take your code to execute, and you can analyze your code on a very detailed base. And you see bottlenecks very fast. It's very important if you work with remote systems like the Tesla API. It often comes to some timeouts, and you can really track down those timeouts with X-Ray, and you can analyze those a little bit better. Then adapt memory and timeout configuration. Most people start with Lambda, create a function, configure very graceful memory settings and configuration and environment variables, but most people don't adapt those anymore. That means you start with 1 gigabyte memory and you never touch it. You never touch the configuration. So make sure to have a look on how many gigabytes or how many megabytes memory consumption you really had, and adapt your configuration, because otherwise you just waste money. Yeah? And as I monitored my memory usage for the Lambda functions, I saw that most of those just consumed something like 50 megabytes. So I could stick with the configuration for 128 megabytes, and that's great, because that's a very cheap configuration for Lambda functions, and you just save some money. Yeah, make use of alias and versioning. So many people also use always, when you invoke Lambda function, you use always the latest alias. So it means the latest version of your code. But you can easily tag those code versions using alias or versioning, and that makes it very easy to deploy new versions to specific stages in your Lambda environment. In general, I use Lambda for the remote connector. So with Lambda, I really query vehicle data on Tesla's side, and I also developed the whole processing logic using Lambda. So there is no really backend in this case on some application server. I use it also for aggregation logic and for the REST microservices. So REST API just consumes the requests of the REST requests and translates those and invokes Lambda functions. And I also use it for event-driven security. I have a slide for that later. And all the Lambda functions are created using Node.js. So to orchestrate Lambda functions, you can use step functions. Anybody using step functions in here? Nobody. Okay.
What is it?
What is it? Well, step functions is it was released on reInvent last year, reInvent 2016, and it allows you to orchestrate Lambda functions. So you can easily configure state machines and design flow diagrams in your application. It gives you the chance to decouple those microservices, and instead of having cascading invocations, you just use step functions to orchestrate those cascading invocations. And it's a way to loose coupling your application actually. And of course you can use configuration over implementation. That means if you want to have a retry somewhere, you don't have to implement it, you just configure it using step functions. It's very cool because you have stuff like failover, waits, and with those features or with those tools in hand, you can create very cool flow diagrams like this one. As you can see, I have two parallel steps depending on which manufacturer is used. In this case, Tesla, or for example BMW. I use different Lambda functions for accessing remote data, and I can perform parallel tasks, so I don't have to wait for a task to be completed. I can start another one in parallel, and if every of those tasks finish successfully, I can aggregate the statistics, update those, and the execution is done. So every of these small bubbles are actually Lambda functions, and they don't know something from each other, so they are completely independent, deployed, and work completely independent. And they are just invoked using special events and special contexts, and are orchestrated using step functions. So if you don't know it, step functions, if you don't know it right now, just have a look. It's great. It's very cheap, and it gives you a lot of power using Lambda. Step functions, the best practice. If you start with step functions, I would suggest to use to start by designing your flow, by designing your diagram, and use pass and fail states. The pass state always passes, the fail state always fails. So you can easily debug your diagram, debug your flow, and see if everything works out for you. And just if you did this step, start to connect microservices behind those flows and connect your Lambda function. Always use retry, wait, and failover. So many people also define flow but don't make use of waits or failover. So you can of course trust that your Lambda function runs in a timeout, but what happens after a timeout? So if you don't define some workaround in your flow diagram, you might have a situation that you didn't test. And in the final state, something should happen. So either publish an event to using SNS, send an email, or I don't know, call Donald Trump and ask for help, something. But something should happen in the end because your execution is done. And if the execution is done, you might want to notify another system that the execution was successfully or failed. And SNS, very easy. It's an event bus in AWS, and you can use it for fan out. So that means you have one event, and a lot of consumers consume those events in parallel and can work with this event. I use COGNITO for managing users and user pools. So the complete authentication process, the registration, confirmation, and stuff like reset password and so on can be done using COGNITO. It's a completely serverless and very cheap solution of AWS for managing authentication and users. And it also works great with third-party stuff like Google, Facebook, and LDAP. And I think they also have Twitter. No, they don't have Twitter so far, but there are some plugins to make use of Twitter as well. But have a look on COGNITO. It's a great way to work with users and authentication. And I use KMS for key management. It's called Key Management Service. It's used for encrypt and decrypt data. It also supports streaming. So if you have blobs or really huge data, huge amount of data, you can stream it using KMS, and you can easily process huge data, and encrypt huge data, and decrypt huge data. And KMS supports rolling keys. So if you decide to update your keys once in a while, KMS can still decrypt your old data and encrypts using the new data, using the new key. That's a great feature, and you can stay always with new key. Every year you release a new key, and all your data is encrypted, and encrypted data can be decrypted still using KMS. Yeah, best practice, or I use it, of course, for remote credentials, for the sensitive personalized data that don't have to be queried, because as soon as you encrypt it and save it to DynamoDB, it's quite hard to query those data. And all encryption is done at rest. That means not moving data. For the moving data, use SSL, but data that stays at rest is encrypted using KMS. And I use CloudTrail. CloudTrail is enabled by default since 2 weeks, I guess. There was an announcement from AWS that they, by default, activate CloudTrail for every new account. And it actually logs all the AWS account activities that happens in your account. So every user that configures some service, every user that logs into your AWS console, every activity is monitored, and that also includes the CLI, the command line interface. And by using CloudWatch rules, you can define some behavior on those CloudTrail events. So if someone logs into your application, logs into your AWS account, you can configure a CloudWatch rule and do something. You get a notification, or you automatically block users that are not allowed to log in. You can react, or you can work with those events, and you have a chance to get notified if some activity is happening in your AWS account. And the best practice for it is actually, you can use event-driven security. That's also a huge topic. That was a huge topic on last year's reInvent in Las Vegas. And there was a nice talk about event-driven security, talking especially about CloudWatch events and handling specific events happening in your AWS account. So stuff like, for example, someone logged in the account and deactivated CloudTrail. So to get rid of all the sensitive stuff that's happening after this step. And there was a LAMBDA function running and listening on those events, on CloudTrail deactivation event, and it automatically enabled CloudTrail again. So actually for the attacker there was no chance to get CloudTrail deactivated, because it immediately enabled CloudTrail again. So stuff like that, it's called event-driven security, and you can actually handle every event in your application, every event in your AWS account, and can handle it using LAMBDA functions. So that's a very great stuff that you can make use of. And CloudWatch rules is the magic word. So if you have a look on CloudWatch rules, it tells you what you can do with all those event-driven stuff. Or if you don't use event-driven security, at least have a look at the CloudWatch rules or the CloudTrail logs, that you see if something strange is happening in your AWS account. And there is something like config rule. Is someone here using config rule in AWS? Okay, no? Have a look. It just takes you some minutes, and with config rule you can allow or deny certain AWS service configuration. That means if you say, I don't want to have my DynamoDB having more capacity than 10 units because it costs a lot, then you can define it in one single place. You can define a rule, and nobody is able to configure a DynamoDB table having more than 10 read capacity. So stuff like that can be done on a centralized on a centralized point. And if you don't know it right now, just use it. It's very easy, and it gives you a lot of power what's happening in your AWS account. And there is the web application firewall. It's also something released last year. At least it got a huge update by AWS. And it's a serverless way of defining rules and HTTP elements to be sniffed and checked for you, like headers, bodies, URL paths, URL paths, and remote addresses. And you can block certain requests or allow certain requests. And you can install your web application firewall in front of, for example, an EC2 instance, in front of a load balancer, or in front of a CloudFront distribution. So it's very powerful, and the best practice is actually you can use it also in conjunction with event-driven security. That means you can process specific events happening in your web application firewall. That means if you detect, for example, that a certain IP addresses is spamming you down with requests for, let's say, PHP MyAdmin. So they try to find some PHP MyAdmin user interface on your application, and you detect those requests. You can automatically handle those events and, for example, block those IPs using VPC network access control lists. And by using DynamoDB and time to live, that's also a feature released recently, you can automatically remove those IP addresses again. So you have a way of automatically block IPs and automatically release IPs if you use Web Application Firewall in conjunction with event-driven security. And those rules can also be updated using CloudFormation. So that means you can version and you can automatically deploy new rules for your Web Application Firewall, and works with Lambda as well. The API gateway is actually a REST API as a service. So because we don't have any cool and fancy short terms for stuff in IT, just call it RAS, because it's a REST API as a service, and it offers you it gives you the ability to create a contract-first approach for REST APIs. So you define your models, you define your endpoints, and you can easily use mocking for providing a stable and designed REST API before actually implementing the REST API. And the very cool feature is throttling and API key management. So it throttles automatically requests for you, and you can define keys that you give to third-party customers or to any customers that uses your API, and you can track down access rights, and you can track down capacities that are consumed by those API keys. And it perfectly integrates with COGNITO and LAMBDA, so the complete authentication process using a REST API can be done with COGNITO for you. Or you implement your custom authorizer using LAMBDA. So it's very flexible, and I use it, of course, for every customer-faced endpoint. So if a user logs into the application and want to query statistic data, I use API Gateway to query DynamoDB and using LAMBDA. And also, as I mentioned before, the inter-LAMBDA communication. So if one LAMBDA function calls another one, I'd rather use a REST API, in this case API Gateway, than directly invoking those LAMBDA functions. So the API Gateway best practice, use contract first. So first design your API, define the resources, the methods, and the models, and play around with it, have a look if it satisfies you, and then start mocking it. So you can easily send data, receive data from your mocks using Postman, for example. You get a feeling for your REST API. And just after that, you really implement those endpoints using LAMBDA functions. Then always use throttling. The defaults are very, very high, set a very high amount, like 10,000 second or 1,000 requests per second, which is quite a lot for a default. So make sure that before you take your REST API to production, have a look on throttling. And you can use your REST API. You can define your REST API and API Gateway using CloudFormation, and that means that you have a version managed REST API as a service. So a new term, RESAC, because they don't have any terms in IT. And this RESAC is a really cool thing because you can define Swagger files and easily deploy your REST API using Swagger, and everything is versioned and documented automatically. Then the REST microservices. If I talk to people using LAMBDA and using REST services by AWS, meaning API Gateway, it always comes to the point how to cut microservices. So I use a domain-driven design. That means I cut each domain to their very own microservice, and I use the LAMBDA function for several endpoints in the API and use request routing. That means you can define patterns that applies from the request that hits your REST API before they hit your LAMBDA function. And in this mapper, you can define some kind of mapping, some kind of key, and you pass on those key to the LAMBDA functions. And with this mechanism, you can easily do request routing. That means you can have one LAMBDA function handling several requests to your REST API. You don't have to implement one LAMBDA function for every single endpoint on your REST API. And you can very easily create a dependency hell if you cut your Lambda functions wrong by using REST APIs. So create a common interface module where you share all the interfaces between the Lambda functions, and it makes it quite easy to have something like inter-Lambda communication. And yeah, more or less the architecture, but all the services I used have alternatives. So I could have used other things than those mentioned. Let's have a look at the alternatives. I could, for example, use SQS instead of the step functions. That means I would have to have SQS and an EC2 worker instance, which is not serverless anymore, versus the CloudWatch, scheduled events, step functions, and Lambda. So if it comes to costs, I would have to have a lot of vehicles managed in my application. I would have a lot of events happening that this pays out, because SQS plus an EC2 worker instance takes you about $30 a month. So before I reach $30 a month with step functions and Lambda, there is happening a lot in my application. I also could have made use of AWS Batch. It's a technology by AWS that offers you very easy batch processing, but also AWS Batch requires an EC2 fleet behind it. So that's very good if you have huge amount of data processed and you want to have static costs. Then you can deploy EC2 fleet behind AWS Batch. That's not a use case for me. So I could have used KINESIS. KINESIS is actually stream processing for big data. It works great in conjunction with Lambda, but in this case, KINESIS just costs a lot more than using CloudWatch, step functions, and scheduled events. So KINESIS really pays off if you have millions of events each day, and then it starts paying off. But it's a very great stuff if it comes to big data, and the scaling mechanism of KINESIS is incredible. I could have also used DATAPIPELINE. DATAPIPELINE is a service, a managed service by AWS that allows you to define an application like I did. You have some connectors grabbing some data from anywhere, and you wanna have something happening with those data. So you wanna put it into DYNAMODB, you wanna process it, you wanna post-process it, you wanna do something with it. So it's great for those things, but it also requires EC2 fleet. So it's not capable of working with Lambda. Therefore, not interesting for me because it introduces fixed costs. And I could use RDS, so relational database service versus DynamoDB, but to have equal availability in my database, so availability zone deployments, multi-AC, and this throughput, I would have to have multi-AC RDS, and with multi-AC RDS we start talking about $50 and more each month, so not interesting for me. Well, the outlook for my application, I might use KINESIS for real-time tracking of vehicles, so I want to have a map and seeing all the vehicles driving on those maps, and this can be done by using KINESIS. This is a very great way to process streaming data. So all the time, data is reaching the application. You want to process it in real time. And maybe there's some use case for notifications. Like I want to be notified if my car drives to a specific location. Let's say I lend the car to a friend of mine, and he's driving and leaving Austria, so I want to be notified. And for example, maybe you park your car while you're working, and you want to be notified if your car moves. So if the police is grabbing your car, you might be notified. That would be a use case. And also the vehicle state. So if something happens with the vehicle, if, for example, if the climate device just starts, if the battery is gone, you just want to be notified. And if we think on what's capable, if we think on IoT devices nowadays and what they are capable of, every IoT device already uses Twitter, so I saw already microwave twittering if when the food is ready. So maybe my car twitters me something, but everybody's talking about bots nowadays. So every application has to have bots. So if you combine all those things like location-based notifications and Twitter and a bot, in the end we got something like this. So this was a great philosopher, actually, many years ago. A car that can talk is completely connected. But I don't have the hairs, so I mean, let's skip this. There actually features I want to do in the future something like fleet management that could be used for rental companies and taxi companies, and yeah, for everybody who has more than one connected car that needs to be managed. And I want to have this great feature to grant remote control privileges temporarily to users in the case this one single friend want to borrow my car in the future. I want to also consume more vehicle states, so like the charge, the location, and the energy consumption, which could be easily evaluated using big data patterns that you combine like the weather, and you compare the weather to your energy consumption, stuff like that could be analyzed on the fly, and kind of driver profiles. So if my wife drives my car, I just want to know how far did she drive, and how fast did she drive, and yeah, how much energy did she consume. So stuff like that could be interesting in future. Then maybe some social stuff. So I wondered if I charge my car at a supercharger and I have a look on the other cars next to me, and I wonder if I might know someone of those, if I already charged with someone charging right now. So this could be done very easily if two people using this application. You can easily see if someone next to you is actually someone you already met on the supercharger. And you can have something like badges. So if you visit several superchargers, you can have some badges. You're the mayor of Supercharger Vienna, I don't know, stuff like that. And of course, eco goals. So you have some gamification factor, which could be interesting if the electric cars and the connected cars, if they boom and if a lot of people drive those cars, you can have some kind of gamification and could make it easy to reach eco goals. And of course, I want to introduce multiple manufacturers. So BMW is also a car that is connected already. I think Audi is also working on something, and Toyota, but Toyota is not providing customer features. So they send a lot of data of their engines in the cloud, but they don't consume any remote commands, and they don't allow you to interact with your Toyota car. But the Toyota cars are already connected, but just one way. Yeah, so let's sum it up. That were my goals on the architecture and the application, and actually I met all of those requirements, and I'm still 100% serverless. And so in the end, I actually achieved my goal. I have an architecture and application with this configuration, and my recommendation to you is just try it out. So if you define your infrastructure, if you design your application, try to do it in a serverless first approach. So if you think on creating a new application, just try it in your mind. Is this application possible to be done with serverless technology only? And is it possible to do it in the cloud? So try to do a cloud first approach and just fall back on hybrid solutions with on-premise solutions, or fall back to server full solution. But try it out, and you will see there is a lot of chance that you can do your application on a completely serverless base. So thank you very much. Actually, that was my talk. If you liked it, you can follow me on Twitter, and maybe we are on YouTube soon with Cloud Brothers, and want to share information and knowledge regarding the cloud to all of you. So thank you very much for listening to this talk.